What's going on, Algebra Bros? It's Mr. C here, and in this video I'm going to show you a technique for solving certain exponential equations. Exponential equations are equations that involve exponential functions. So as it says here, in order to solve equations involving exponential functions, i.e. exponential equations, we make use of the following property. Now I just want to preface this by saying that some exponential equations do not lend themselves to using this property. We'll investigate those other fancy or bougie techniques later on. But for now, we'll have exponential equations that can be solved using the following property. And that property is known as the one-to-one property of exponential functions. And it basically says this. If you're able to write each side of the equation as the same base a raised to, in most cases different powers, then we can set the powers equal to each other as long as the bases are the same. So if a to the x is equal to a to the y, then the only way that equation holds true is if the exponents are equal to each other. Alright, so if we can write our equation such that each side is using the same base, then we jump to a second equation which involves just the exponents. And by the way, just a little thing that goes on in my mind, I like to think of this as like the fishing lure technique, because this whole oval with the arrow hooking down and everything just kind of reminds me of a fishing lure or a fishing hook. Alright, so if you hear me refer to the fishing lure technique, then that's what I'm referring to as this one-to-one property of exponential functions. So I want to take you through a couple of quick examples in which case we can use the fishing lure technique. We'll do example 1 and 2, and I'll save examples 3 and 4 for a different video. But in example part 1, we have 2 to the power of 2x minus 1 equaling 4. So you'll notice that the base of the exponential expression, which is the left-hand side, is a base 2. And on the right-hand side, we have the number 4. Now, if we could rewrite 4 as a power of 2, then we'll be able to apply our fishing lure technique, or the one-to-one property for exponential functions. So I think we all have an idea of how we can rewrite 4 using a base 2. 4 is the same as 2 squared. So we have 2 to the power of 2x minus 1 equaling 2 squared. And so you'll see that these two bases match each other, meaning that we can now apply the one-to-one property for exponential functions, where we take 2x minus 1 and we set that equal to 2. And we'll just go ahead and solve this real quickly by adding 1 over. That's 2x equals 3, and we get x equals 3 over 2 as our final answer. And of course, you could check this answer by plugging it back into the original equation. Now for example part 2, we have 3 to the negative x. So negative x is in the exponent of 3, meaning that 3 is a base. And then we're setting this equal to 1/9. So if we could rewrite 1/9 as some sort of expression 3 to a certain power, then we'll be able to apply the one-to-one property for exponential functions. And it just so turns out that 1/9 is the same as 3 to the power of negative 2. So what we're saying now is that 3 to the negative x is equal to 3 to the power of negative 2. And since we're using the same base of 3, we can take the exponents out of this context, set them equal to each other, and then solve for x to get x equals positive 2. And of course, this can be checked by plugging it back into the original equation, which would basically say that 3 to the negative 2 is equal to 1/9, and that's definitely a true statement. So it works. Alright, that's where the pain and fun and excitement for this video ends. I want to thank you guys for watching, and I will see you in the next one. Take care.